Today we're going to talk about perfect competition. Our goal is to understand the characteristics of perfect competition market structure. Let's go through the assumptions behind perfect competition. And while we do that, let's imagine an example. Let's say pumpkin industry. First of all, we're assuming that there are thousands of suppliers. Second assumption is that they're all making more or less standardized products. Now, easy to imagine no major quality difference between Farmer Jones's and Farmer Smith's pumpkins, let's say. There may be jack-o'-lanterns and pie pumpkins, but those are two different markets conceivably, or subparts of one market. Third assumption is that these pumpkin growers are profit maximizers. Now that sort of zeroes in on a set of decisions and behaviors that we can describe and predict. The fourth assumption is that all of our pumpkin manufacturers face identical cost functions. 5 and 6 indicate that it's relatively easy to both get in and get out of this industry. For example, I want to get into the pumpkin industry, so I get a seller's license, hand-painted sign in the back of my truck, and some pumpkins harvested recently, and I'm in business. Likewise, it's easy to get out of that business. The seventh assumption is that pumpkin manufacturers are price takers. They take what price they can get. The eighth is that they are quantity adjusters. They do have some control over how much they produce. And finally, all relevant information is accessible to buyers and sellers. Here's a diagram of a perfectly competitive market structure, such as pumpkins. We've got on the left-hand side an industry diagram with the supply and demand determining equilibrium price and equilibrium quantity. And that diagram, in turns, we've got this little dotted line here symbolizing that this representative firm on the right-hand side is a price taker. So equilibrium price 1 is, to this representative firm, lowercase p1. And then we've got our cost functions. We've got average revenue equaling marginal revenue at a constant level. We've got lowercase q1 as the equilibrium output, and the firm is maximizing profit. So let's just take a look at that diagram. That's in long-run competitive equilibrium. And let's zero in on this equality here. We're assuming that the price of the product is equal to its average revenue and its marginal revenue. And so here are some simple numbers that will drive that point home. In the first column we have the price of the product. Let's say it's $2 a piece, no matter how many we sell. Second column is quantity, some possible quantities demanded. Price times quantity equals total revenue, and then we can calculate average revenue and marginal revenue. So obviously just price times quantity is going to be these quantities in the third column, total revenue, 0, 2, 4, 6, 8, and so on. But if we wanted to calculate total revenue, average revenue, that's total revenue divided by quantity. So 2 total revenue divided by quantity 1, that's 2. 4 total revenue divided by 2, that's also 2, and so on for all of these. So price and average revenue in pure competition are identical. Likewise, the derivative of total revenue with respect to quantity, or the change in total revenue for every 1 unit increase or decrease in quantity, is marginal revenue or additional revenue. So going from 0 to $2 is a change of $2. Going from 2 to 4 is also a change of 2, 4 to 6, and so on. So all of these marginal revenues are also 2. So that's why we've shown why the price of the product from the representative firm is equal to average revenue, which is also equal to marginal revenue, and constant. Now let's put this in a story. We'll call it the equilibrium-disequilibrium re-equilibrium story. Here's the Cliff Notes synopsis. We start with profits equaling 0 right here. That's followed by, let's say, an increase in demand. It could be a decrease, but let's just say that we're some positive news about pumpkins. Let's say their health food characteristics are much in the news recently, and so the demand for pumpkins goes up. That's followed by a shortage in the pumpkin industry that is defined by the quantity demanded being greater than the quantity supplied. That's followed by upward pressure on equilibrium price, which is followed by an increase in the quantity output. Remember, one of our assumptions that representative firms in perfect competition are quantity adjusters. So here they're adjusting quantity upward. That's followed by positive economic profits. That's followed by new entrants coming into the industry. So supply would go up. That's followed by downward pressure on equilibrium price for pumpkins. And that's followed by quantity adjusters, veteran firms that are already in the industry, reducing their quantity output because they are profit maximizers. And that is followed by a return to 0 economic profits. Okay, we've read the story, we've read the book, now let's see the movie. The equilibrium, disequilibrium, re-equilibrium story in diagram form. So we start in long-run equilibrium. We can recognize this as the diagram we saw at the beginning. Supply equals demand. There are no shortages, there are no surpluses. And in a moment we'll see why there are also no economic profits. The first part of our story is that demand increased for some reason. I think we said the health qualities. In the immediate period, there's the quantity supplied on this function, but here's the new quantity demanded. That's a shortage. The quantity demanded is greater than the quantity supplied, and here's the shortage. Markets abhor a shortage, so that drives the price up. As price increases, the law of supply says the quantity supplied increases, and the law of demand says as price goes up, the quantity demanded goes down, until that shortage is cleared. That dictates a new, higher equilibrium price to representative firms. So in the immediate term, this representative firm is not, on the right-hand side diagram, is not maximizing profit. Profit, you'll recall, is maximized at the output, which equates marginal revenue and marginal cost. Here's marginal cost. It's an up-sloping function. And here's marginal revenue. So at this output level, Q sub 1, this firm is not maximizing profit because the new marginal revenue is here. Marginal revenue 2, let's say. Because that equilibrium price was driven up by the shortage in the industry, in the market. So this firm can adjust quantities and increase profit by increasing output. Let's say planting more acreage in pumpkins. So there's the new quantity output, Q sub 2. And at Q sub 2, we go up until we intersect average total cost, multiplied times quantity output, and then recognize that this rectangle, the shaded rectangle, is a profit, an economic profit. Here on average is the average total cost times quantity. So this area is the total cost of making Q2 P2 output. But total revenue is P2 times Q2, which is larger. So we can see that the total revenue is greater than the total cost, and that difference, that hash mark difference, that little rectangle on top, is the profit zone. those economic profits are very hard to resist. So new firms, new people looking for new business opportunities are going to be attracted. That's a signal. Come into this industry, come into this industry. And as they do, supply 2, let's say supply 3 is when the process starts, you'll notice that the new demand and the new quantity supplied of S sub 3 drives the price back down to the original equilibrium price. That is communicated to both the new firms that have entered and the veteran firms that have already been there. And what happens is the quantity adjuster will have to, in order to maintain maximum profits, will have to reduce output, take some acreage out of pumpkin production, let's say, until we're back to the original, where price 1 and quantity 1 define the long-run equilibrium, the long-run competitive equilibrium, and where profits are competed away. As price is dropping, that profit rectangle is shaved away, and that happens until we return back to assuming a long-run constant cost. These are 2 points on a long-run supply curve, and it's horizontal, which suggests that long-run supply suggests that this is a constant cost industry. In other words, cost functions, marginal cost and average total cost, do not change as new firms come into the industry. It looks like we've returned back to everything being the same, but it's not really. The industry is larger because people wanted more pumpkins. And so the story and the movie illustrate the fact that profits attract new entrants, people get more pumpkins, which is what they wanted, and profits are eventually competed away.